All right, example 11. Water is leaking out of an inverted conical tank at a rate of 15,000 cubic centimeters per minute. At the same time, water is being pumped into the tank at a constant rate. So let's first off, before we start figuring anything else out, let's just draw the picture correctly. An inverted conical tank means it's a cone, but it's upside down. So the base is facing upward, so it would hold water. So they're expecting a cone typically to have the circle on the floor pointing up. They've got the circle at the top pointing down. So inverted conical tank. Okay, water is leaking out of the tank. There's a drop of water coming out of the tank. Probably a little bit more severe than that, but we're going to have it dripping out like that. At the same time, water is being pumped into the tank at some speed. There's water being pumped into the tank. All right, if we continue reading. The tank has a height of 8 meters and the diameter of the top is 5 meters. All right, so that is just dimensions of the tank. That's not dimensions of the water in the tank. So the tank is 5 meters across and 8 meters up and down. All right. Due to the fact that there's units of centimeters, this is cubic centimeters per minute. The water is rising at a rate of 12 centimeters per minute. Let's just, for the sake of making things all the same unit, I'm going to say this is 800 centimeters. And I'm going to say this is 250 centimeters. And the reason I'm calling that 250 instead of 500 is because it said the diameter was 500, right? So the radius is 250. That just doesn't want to cooperate. There we go. So 800 centimeters and 250 centimeters are going to be the radius and height of the tank, right? Any concerns yet? Pretty straightforward. Again, I put numbers there because the tank's not changing, right? We're not pumping water in at the same time the tank's doing weird stuff like this and getting bigger and smaller. So the tank is just there. It's a metal tank. It's made of metal. It's staying just as it is. So that's how big the tank is that we're pumping water into. And it's also leaking. The water level is rising at a rate of 12 centimeters per minute when the height of the water is 3 meters. So the water in the tank is about here, let's say. All right? And we know the height of the water at the moment in time we care about, but the height of the water is changing, right? It tells us the height of the water is changing 12 centimeters per minute. So it's rising in this tank as we go. So the height of the water is a changing dimension. So I'm going to put an H there for the height of the water. And wherever the water's at, the radius is also changing. Right? As the water gets higher up, the radius is getting bigger. All right, so the radius is increasing, the height is increasing as the water goes up. If the water was going downward, the height and the radius would both be decreasing. Everybody comfortable with that? And again, the key to these problems, getting them right, is when you draw your pictures, know when to use a number, know when to use a letter. So the simple question you have to ask yourself is, when you draw the picture, is what I'm drawing moving? Okay, the water's moving, it's going up. So this is changing, those that we're using letters to represent it. The tank itself is set in metal, actually. I was going to say set in stone, but set in metal, so it's not moving. All right. Looking at that picture, does anybody see any kind of shape that might be helpful in getting a relationship between R and H? Triangle. And specifically overlapping triangles, right? We're assuming the water is going to be a right angle here. This is at a right angle up here. So we have overlapping right triangles going on there, making them similar triangles because, of course, the angle down at the bottom is the same angle. This angle, therefore, equals that angle, right? So I know that if I put R on top and H on top, 250 goes underneath R and 800 goes underneath H. If I cross multiply that, I get 250H is equal to 800R. Now you have to make a decision here whether you want to get H equals something about R or R equals something about H. And what makes my decision for me is this right here. The water level is rising at a rate of 12 centimeters per minute. Is that DH or DR over DT? DH, right? The height of the water is changing, right? DH over DT. So if I can get everything in terms of H, that's probably better for me than getting everything in terms of R, right? So what I want to do is get this to say R equals something about H. So I'm going to get R out of the problem. Whatever you want to get out of the problem, anytime get that letter equal to something else. So, if I divide both sides by 800, reduce as much as possible. Let's see, 250 divided by 25 is 10. 800 divided by 25 is 16. We'll go one more step from that, 5h over 8. That seems wrong. Sorry. This is 32. My division's bad. 32, so this would be 16. There we go, 5h over 16. Alright, so that type of stuff is important sometimes. I've got one exact, I've actually got two rates. Alright, I've got how fast the water's leaking out, right? But let's just ignore that for right now. Let's pretend that wasn't there, okay? Because that's not the change in volume of the water, that's how fast the water is dripping out of the thing. We'll have to worry about that in a little bit. Okay? For everything not involving the leak, we know how quickly the height's changing, that's all we know, right? So we're going to find out how much the volume changes. We want to find out how much water is being pumped in here. We want to know the volume change of the actual water in the tank. All right, so I only have one rate, which means I get to use two variables. I'm trying to find change in volume. All right, so H equals something, V equals something, dH over dt equals something, and dV over dt equals something. And the trick to this is that the volume that's leaking out of the tank is irrelevant right now. It's very tempting. It's a change in volume. Let's put that right there, but that's not the change in volume. All right, that's just how quickly the water's draining out, which is causing us to have to pump in even faster to make this height change happen. All right, so ignore this until the very end. Anytime you have water in a problem and it's leaking out, it doesn't matter until the very end. I'll show you how to handle that one when it comes to it. So, what's dH over dt? 12. Is it positive 12 or negative 12?
Positive.
And it's positive because the water is rising, getting bigger, H is getting bigger. So positive 12 centimeters per minute. What is H equal to? 800 is the height of the tank. Is what we're dealing with the height of the tank or the height of the water?
It'd be 3.
8 meters.
8 meters is the height of the tank. So say again, Claire?
3.
3 meters. So it's going to be 300 centimeters. And be careful when you're doing a problem involving volume, it's helpful to have all the units in the same type of unit. So whatever the volume unit is, I would go with that for the regular units. It's easier to do that conversion than it would be to change the volume to the other unit. Volume I can find out, we're trying to find out the volume of the water, right? So the water's in what shape?
Triangle.
In that triangle.
Cone.
A cone, right? Three-dimensional. It's a cross-section there, but yeah, it's 3 dimensions of the cone, right? The water's in the shape of a cone. What's the formula for the area of a cone? Oh, sorry, not the area, but the volume of the cone.
I forgot.
On that sheet that I gave you in freshman year that I told you to memorize before you were seniors, that one there.
Volume of a cone
Volume
is
is 1/3.
1/3 base
times
times
height.
Base times height. And base is area, base and height is height, right? So, what's the area of the base here? Again, looking at just the water, radius is R, the height is H. What's the area? Hint, it's a circle. And we're trying to find the area of a circle with a radius of R. Pi r squared, thank you. And the height is H, right? So 1/3 pi r squared H is our volume formula. And again, that's a relating formula between V, R, and H, but the problem is we don't know anything about R, do we? So what I need to do is I need to convert this R into 5H over 16, so then I get an equation just involving V and H, right? And one thing I would do, personally, it's not a requirement to do this, if I multiply both sides of this equation by 3, I'm going to get 3V is equal to pi r squared H. I just think that's going to be easier to work. Alright, so if R equals 5H over 16, that means 3V equals pi times 5H over 16 squared times H, which means 3V is equal to 25 pi h cubed over 256. Take a moment to digest that. Make sure we see where everything came from. Five squared is 25, h squared is h squared times h makes the h cubed. The pi is on top, and 16 squared on the bottom is 256. Right? And again, the 3v on the other side, if I kept the 3 over here, it's just going to multiply by the bottom. I could even multiply both sides by 256 right now if I really felt like it. If you don't like fractions at all, you can make them go away. It's an equation. So that's a relating equation. So is this. This is also, but it's no good because it's got too many letters in it. So once you change R to H, at any moment in time when you do that, you can go with it, but I like simplified versions better, so I'm going to go with this bottom one. I like that bottom one a lot. So 768V equals 25 pi h cubed. 768V equals 25 pi h cubed. All right. Do I have to figure out what V equals?
No,
No, why not?
because it's gonna go away.
Yeah, when I differentiate, this is going to go away, right? So the fact that we don't know V is irrelevant. So we can just go ahead and differentiate now. So I know what I need to know. I got h and dh over dt. I don't care about v because it's going to go away, and dv over dt is what I care about. That's what I want to find. So the derivative of 768v is 768. We're going to do dv over dt because v is not t. The derivative of 25 pi h cubed is going to be 75 pi h squared. And again, fight the urge to do the product rule when you don't have to do it. dh over dt because h is not t. This is not a product rule because 25 pi is just a number being multiplied by a letter. 3 times the number makes the new number, drop the power by 1. No product rule necessary because it's not a product of letters. It's a product of a number and a letter. Simple power rule is necessary there. Once I get to this point, what I care about is this, what I know is this and this, so it's just a matter of substituting stuff in. So dv over dt times 768 is going to equal 75 pi times h squared, that's 300 squared, times dh over dt, that's 12. Divide that by 768. So dv over dt equals that thing, and that thing equals something. Let's see. 75 times pi times 300 squared times 12 divided by 768. I hope it equals 331,000 something.
You got
Oh,
times by
no,
You
1.
got times 1.
Oh, good. I was going to say. Hope it equals 331,000 and something, because that's what it equaled earlier when I did it.
Whoa, how did you just click that button and your whole equation came up again?
If you hit second and enter, it brings up what you last typed in.
Oh.
And then you go back and I just did that and I put an insert to throw something new in. So like, let's say that's missing and I need something there. Second, insert, and then you type in what you want where it belongs, where it's blinking is where it's going to go. And until you move, it's going to continue to allow you to insert. Once it's that black cursor, now you can't insert anymore. So if I type anything now, it's going to overwrite what's there.
Mm-hmm.
So if you're inserting it, it's got a blank, I guess a transparent cursor that blinks. You can see where it's blinking. That's where it's going to put the thing and move everything over. All right, so 331,339.8502. So dv over dt equals 331,000. I can't remember the rest of the numbers. 339.8502. 339.8502 centimeters cubed per minute. All right. Now, this is not the answer. Almost the answer. All right. What's happening that we haven't accounted for yet? It's leaking, right?
Why has it got to be weekend?
Because that makes it more interesting. It doesn't make it any more difficult. It's one extra thing to think about at the very end after your brain's just been fried a little bit by this problem, right? But it is one extra thing to think about. What that thing there represents, this dv over dt, because we ignored the leaking water, right? We pretended it wasn't leaking. That represents the volume change of the water within the tank, right? Two things are influencing that height of the volume of the water in the tank. How much is going in and how much is going out, right? This is how much needs to be going in without a leak in order to fill this tank at the proper speed so the height is changing at 12 centimeters per minute, right? So what I need to do is our choices are either add or subtract the 15,000. Before you answer, I want you to think it through. Okay, this is how quickly the volume of the water has to be changing in the tank to make this happen. We have water going in, we have water coming out, we need the end result to be this. So do I need to pump more water in to account for the leak making things go out, or do I need to take water away and have the leak taking things away also? So think about that. Which one should we take? We have to add the 15,000, right? We have to add more water. So this is how much the volume change has to be. I have to make this 15,000 more than what I need to account for the 15,000 leaking out, right? So I'm going to add 15,000 to that amount. So plus 15,000. Use good decimal addition facts of 2,058.93364. 346,339.8502 cubic centimeters per minute is what would have to be pumped in order to account for everything that's happening in this problem.
That's a lot.
It is a lot. Maybe they're at the Yankton Dam. You ever seen them when they have those gates all the way open? That's pretty impressive. Very powerful. So that's that. And again, the thing I'm going to warn you about as far as the relationship between this and any problems you have in your homework, if volume is involved, make sure the units of the dimensions are equal to the units of the volume. It's much easier to change the dimension units than it is to change the volume units. So go ahead and modify your dimensions rather than the volume. All right?